the thing that was tried before and never worked, like do everything all at once. We were like, I think we can do that now with end-to-end deep learning and with the techniques that we saw in physics, et cetera, and just do it all in one shot, and then it will be better, faster, cheaper, more reliable, et cetera. And the short version of that story is it worked, and that's the product that Deepgram has today.
Welcome back, VoiceBot Nation. I'm Brett Kinsella, founder of VoiceBot.ai, and your host for the 10 Minutes On series, where we explore the new applications coming out of the voice AI world. And today I have a special guest, Scott Stephenson, CEO and co-founder of Deepgram. And he's here to discuss how scaling of voice AI technology is going to introduce a whole set of new applications that have never before been practical. Scott Stephenson, thanks for joining me today.
Yeah, thanks for having me.
Okay, so you have a really interesting origin story. Deepgram is the automated speech recognition system that was created 2 miles underground. Tell me about that.
True. Yeah, we were physicists back in the day. Deepgram started a little over 6 years ago, and we were physicists at the time building deep underground dark matter detectors. So these are particle detectors that are like 2 miles underground. I was in a government-controlled region of China in the foothills of the Himalayas under a mountain. So it was very much like a James Bond lair. And we were looking at signals coming from dark matter events and other events that are happening inside the most sensitive detector in the world. And the signal processing that happens there and the types of models that you need to use in order to understand the particle physics actually works really well in the audio world. And so we noticed that, and we noticed the need in the world and how it could scale really well, and how if you couple end-to-end deep learning with really good hardware and a first principles thinking, which is what physicists like to do, then you can reinvent the way that speech recognition is done.
And how is this different than what the way other people were thinking about speech recognition at the time?
Yeah, and actually, it's not just at the time either. It definitely was at the time. It still is how our competitors operate. But the way that people used to do speech recognition was they came from the premise that speech recognition is really hard, and you need to break the problem up into different segments. And because they tried to do everything all at once before and it didn't work. And it's like, okay, well, if we break it up into segments, we might be able to do it. And they're pretty logical. So the original first part would be, hey, can I just guess the phonemes that people are saying? So in other words, ah, oo, k, the, z, just not the words, just like what are the fundamental sounds that they're making. And then the next step would be, okay, out of all those sounds, what are the candidate possible words that could happen? And then once you have that, now it's a list of words, and now I have to cut it down into just the one single transcript. And each of these steps, it was its own model, and it was done in a very like computationally intensive and memory intensive way. And it's done in a way that a human can understand pretty easily as well. Like you make lists, and it
Right.
takes up a lot of space and that kind of thing. Um, but yeah, the way that we came at the problem is an end-to-end deep learning problem. So you take out the thing that was tried before and never worked, like do everything all at once. We were like, I think we can do that now with end-to-end deep learning and with the techniques that we saw in physics, et cetera, and just do it all in one shot, and then it will be better, faster, cheaper, more reliable, et cetera. And the short version of that story is it worked, and that's the product that Deepgram has today.
Yeah, it's a really fascinating origin story about taking technology being used for something else, applying it to a problem that people are already trying to tackle in a different way, and doing it at a time when the technology is emerging to the point where it can actually do things that it wouldn't have been able to do a decade earlier. So you didn't have the technical debt that a lot of the other people working in the space had. Now, you mentioned this idea about speed and scalability, and you and I have talked about this a little bit. And I want you to share with the listeners today a little bit more about when you think about scaling in this space, what does it mean?
Yeah. I think in the beginning, accuracy matters, but once accuracy becomes pretty good, which is kind of the state of the art today, is pretty good. Then the next thing that matters is the scale, is cost. In order for it to have widespread adoption. So what I mean by that is, hey, if you can make the cost of speech recognition 10 times cheaper, then you'll have 100 times more adoption. You'll have way more usage, and you'll see it all over the place. And so right now the cost is, if you went to if you just looked off, just look on the rack, what you can get from competitors, and so Google, Amazon, that type of thing, they'll be around $1.50 to $3 an hour, is how much it costs. And if you're a meetings platform, or you have a huge call center or something like that that pumps through a ton of data, that cost is like totally prohibitive. You can't do it. You'd be giving them hundreds of millions of dollars a year, and like that just doesn't work. You need to cut that down by a factor of 10, a factor of 100, or something like that, in order to enable these other use cases. And um, so if you use end-to-end deep learning and you hardware accelerate it on GPUs, and you pair those together and put a lot of R&D in order to like reinvent everything, then you actually can hit that order of magnitude or more cost reduction. So you can go back to those customers and say, hey, remember that thing that you thought was totally impossible before? Now it's possible. You can actually do it. What if you could transcribe everything, And then their eyes light up about the products that they could build. And this is true of audio, but it's also true in images and video processing and text processing. They're all going to happen kind of in the next few years. You'll start to see cost reduction come in, quality still go up, and then widespread adoption.
Okay, so this is a really interesting idea, because most people think about scalability, how many people or how many conversations could I handle per minute, for example?
Hmm.
And they think about load on the system. But you're talking about scalability in terms of efficiency,
Hmm.
computational efficiency, because that's one of the key drivers, obviously, that's doing this $1.50 to $3 an hour cost.
Hmm. Yeah, absolutely. Thanks for bringing up the different ways to look at this. Yeah, there is definitely a difference there. A lot of people might think, well, you could just scale horizontally, or in other words, just add more machines, or just spend more, basically, right, and then do more. And for us, we're like, hey, that doesn't that you that doesn't work. Not at the scale that it needs to happen. Like it doesn't work. People are not going to be able to spend $2 an hour in order to transcribe an hour long meeting, for like that. Just it doesn't work out. And it needs to be 10 cents. It needs to be in that range. And then the economics work out. So yeah, but with that, actually, with that cost reduction side, you get all of the other things for free if you do it correctly. The reliability side, the ability to scale up and down quickly and whatnot, because you need way fewer resources in order to do it. So anyway, yeah, you get both for free, but it really, we target the cost side, for like actually rolling out a product at really large scale, and not having the underlying hardware cost and memory that it takes, and CPUs and GPUs and all that stuff be the driving factor for the cost. It should be the R&D to make the models better. It should be labeling data. It should be, et cetera,
Yeah,
that
sure.
kind of thing.
Yeah, so I'm interested in the GPU angle, because I think the state of the art is to use CPUs for
Hmm.
processing. What is it about using the GPUs? Obviously, they're more capable, but what is it that
Yep.
you've done with them to optimize with your models in order to get so much more efficiency?
Yeah, the general idea with GPUs is that they're dumber than CPUs, but there are way more processors. A couple orders of magnitude. And so if you can formulate your problem in an easy to understand way for the GPU, like so that it's easy for the GPU to understand. So if you can translate your problem into GPU land, and maintain accuracy and efficacy and that type of thing, then it's definitely going to be at least 10 times faster. It'll probably be more than that, actually. But this is because you've got a really big hammer, essentially. So if you can make everything look like a nail, then it can really go through them. And but the one of the drawbacks is that rigidity. You have to make everything work. You have to make everything look like a nail. Whereas with a CPU, you can say, well, we need more flexibility. It's really hard to change things and make them look like a nail. So we'll use the more intelligent processor and whatnot. But it just jacks up the cost. So yeah, the GPU has been it started as like a workstation CAD thing in the 90s. And then gaming really pumped
Right.
that up and turned those processors into amazing matrix multiplication machines. And in deep learning, that's what you're doing. Like everything, if you can make your problem an end-to-end deep learning problem, then what you're doing is trying to take everything and turn it into a matrix so that it can be multiplied with some other matrix. And if you can do that, which is very hard, but if you can do that, then you get these massive benefits.
Yeah, that's amazing. Okay, so we've lived all these years without transcripts from all our call centers or all of our meetings and things like that. So, what is it that's compelling people now that the cost is coming down to do this? Is it just because we have so much more of this data and we feel like we've leveraged all of our data elsewhere that we can to its maximum effect and we're looking for the next great breakthrough? Or is there something else that we've really been missing, that there's these new capabilities that, having that full transcript, having the learning mechanism, having the analytics on the background really makes a huge difference?
Yeah, I think what you mentioned is part of it. I think the but I like to step back as a human and think about if you had like your best friend, next to you, and that person was an expert in whatever the thing is that you're trying to do. Would you still go to Google, type things in, and try and figure something out, or would you just turn to them and like ask them, hey, how can I do this, or how can I whatever? So there's like a if the knowledge is available, if you can just speak and not have to do something else, type, click, go through all the things, that like we would naturally choose that over those other methods. The only reason that we choose the other methods is because it's not available. Essentially, it's not the accuracy isn't there, or the products aren't built yet, or something like that. And so I see like it's kind of amazing. Around a third of most meeting interactions, people will turn on somebody in the meeting will turn on closed captioning, and so you would think that maybe it's like at the percent level or something like that, but it's a lot of people who will actually do it, and it's not just because they're hard of hearing or something like that. Like they maybe they're paying attention, multitasking or something like that, and they'd like to wait, what did they say, can I go back and look at it, and that type of thing. And so there's a lot of reasons in our like new modern highly loaded digital life that make it better to just have some kind of exoskeleton from AI and automation to like make your life easier, to keep track of things better. And audio is one way to do that with transcription. And there's other understanding things that you can do on top of that too, like what topic were they talking about? Were they upset or not? Sentiment analysis and that type
Sure.
of thing. So all these things are coming, but yeah, it's several things all at once. But we've always wanted them. Just like when you have a
Sure.
human next to you, you'll turn to them and ask that. But we just we were denied before because the technology wasn't there, but now it is.
Yeah. So what application are you most excited about that this enables?
Oh man, I get excited about a lot of things, but I think I like the particular topic that we're talking about right now on the scale side, that really does get me excited. That's the physicist nerd inside of me, where if you can have accuracy, that's great. But if you can have accuracy at massive scale, then you change the world, basically, right? Like you're the one that can bring the product. Our company is the one that can bring the product to the world. That allows us to not just have toys or demos or something that use speech, but to just make it totally real. So you can have a really big effect. But I think there are also some really cool use cases. I can't wait until I can be driving in my car and just say things to it, and it actually does the things that I would want it to do. You're trapped in your car. You're held hostage in there. And like I said, if there was a person next to you, if you had a co-pilot, you just talk to them and say like, "Hey, can you do this? Can you do that?
Sure.
Whatever it is you need to do." But even the voice assistants built into even fairly modern cars like Tesla and others, they're still not like that. They're very command and control, and very like you really don't use them. They're still very limited. So I can't wait until our lives are made easier on that side. And then also another kicker is just when I can call a call center and have in 5 minutes have my problem solved and me leave happy. Like
Right.
that because I think that will actually also come too because of automation through better training of individuals using AI. through better call routing, through et cetera. And like that's something we'll all see in the next 5 years. So yeah, really excited for all these things.
Perfect. How can the viewers learn more about Deepgram?
Yeah, you can go to deepgram.com. Also, if you're a product builder or a startup, you can apply to our startup program to get free credits. And if you're anybody can go try Deepgram. Just sign up for free, you get free hours, and you can try it out. Transcribe in real time. If you're a programmer, you can upload through an API, etc. But yeah, that's where they can find us.
Yeah, perfect. Scott Stephenson, thank you so much for coming out today.
Yeah, thank you.
Hey, thanks for watching. Please like this video and subscribe to help us with YouTube's famed algorithm. And it'll be good for you too, because you'll be notified when the next 10 minutes on video drops, and you'll have that information before everyone else. So please like, subscribe, and may the voice bots be with you.